What's up, Algebra 1? We're going to be doing some domain and range problems. So I will do a few of them. I think I'll do like maybe 2 or 3. And I'll talk about the other ones just to kind of get you going a little bit. So today we talked about domain and range. Domain has to do with the possible x values. So since this is the x-axis, we're trying to analyze this graph to see like what x values are possible. For example, 6 is not possible. There's no graph, no y point that corresponds when x is 6. But it does correspond when x is 4 or lower. So I would describe all of the x values here as being lower than, less than, or equal to 4. Basically meaning as long as x is 4 or less, you're going to have some graph for those values or output y values when you consider like when x is 0, y is 2. Or when x is -5, y is 3, and so forth. So all the other values, like values greater than 4, like 5, 6, 7, 8, there's just no graph, there's no output for those particular values. So range, that's more of the output. What do you get out when you're plugging in these x values? So instead of thinking left and right, I'm more thinking up and down. And what I notice is that there's no graph down here, which is where all the y values are negative. The very first value is when y is 0 or 1 or 2 or 3. And that arrow suggests that it just keeps on going up and up and up as x becomes lower and lower and lower, -10, -12, -1,000,000. Y just keeps increasing, going up and up and up. So what I would say for this is all of the y values have to be greater than or equal to 0. There's no y values that are negative in this case. So think about it left to right. It goes as far right as 4, and it's from that value down. So x is less than or equal to 4. Or if I'm thinking about up and down, all the y values are 0 or greater. So let's look at this circle graph. If I'm looking at how far left and right it looks like it goes as far left as -2 and as far right as +2. And really there's graph anywhere in between them, but nothing outside of that. So that's what I'm going to do. -2 to +2. That's kind of my barrier points. Domain is x. And I don't see any of those open circles like I see on this graph over here on number 9. So I think I'm just going to consider that it does touch when x is -2 and when x is +2. Right there is a point, and right there is a point where I do actually get output. Now, as I think about y is up and down, and so there's no graph below 1, there's no graph above 5. So basically all of my y values are trapped between when y is 1 and 5. Between -2 and +2 left and right, between 1 and 5 up and down. Alright, so I'm going to kind of look and see one that I think would be a little bit tough. Let's talk about this one. So this one, if I'm thinking about the domain, that's the x values. It goes forever left and right because that arrow suggests that it continues to the left as well as continuing to the right. Sorry. So I'm going to basically say that it goes forever left and right, and so I can either write the words all real numbers, or I can learn this symbol which represents the phrase all real numbers. Spelled correctly, of course. So that is just another way that you don't have to write that whole phrase. You can just learn this symbol, and that means the same thing. You also see it on different tests every now and then just to test your understanding of that symbol. So the range is the idea of the y's in the up and down part, and if I'm looking at this closely, it looks like all of my values are below 1. Okay, it goes down forever. There's a graph going in the negative direction forever and ever and ever, but it looks like it does not exceed 1. So I'm going to say all of my y values are lower than or less than or equal to 1. And I am going to use or equal here again, mainly because there's no open circle that would suggest that doesn't touch there. Sorry, I picked the wrong option there. So forever left and right, domain all real numbers. And range, it goes from 1 down forever. So I use less than 1. All right, so again, because this is non-accuracy, I'm not grading it based on accuracy. I'm really just wanting to see what you put. It's only so useful to watch a video and me tell you all the answers. So you need to have a few that you're doing independently, and you can kind of see if you think it's right or wrong tomorrow. So 8 and 9, 10, 11, that's all you. If we have just a moment, I'll talk about the solving for literal equations for just a moment, and how about I do these two and you try the other ones, which I think is reasonable. So if I'm trying to solve for r, I'm going to first in my mind locate r. R is right there. It's kind of hard to show just r, but r is right up against t. So that means that if I want to get r alone, I need to divide t away, and you really need to know that when things are up against each other, that means multiplication, and that really helps you understand how to move things, or just in general how to compute things in algebra. So I've got r alone, and what can be hard is that r is written on the left now. So r is by itself, and carefully d is on top. That's distance, by the way. And t for time is the number that's being divided. Now you want to be real careful because there are two very close answers here, and you did move t, you divided t over, and so this one is the one that we want. Okay, so this is the simple interest formula. P is your principal, like how much money you borrow from the bank initially. R is your percentage rate as a decimal, and T is time. Not that you need to know that at all to do this problem, but just so that you don't think that this is some made-up formula. In fact, I think every formula on this page is some actual formula. Like this is area of a triangle. This is volume of a pyramid, if I have that correct in my brain. This is perimeter of a triangle. If you have 3 sides and you add up all 3 sides, A, B, and C, then you know how far around the perimeter is. This is one we talked about. This is perimeter of a rectangle. You have 2 lengths and 2 widths that are the same. I've seen this before, but it's been a long time. I know that this is basically a form of the interest one that we just talked about. It's like your starting principal amount, and then you're adding on how much interest you get over time. So that, I think, is pretty much what that formula does. This is the area of a trapezoid. A trapezoid is a geometric shape that only has 2 parallel sides. So for example, these are parallel, but the other sides are not. So when we're talking about big B and little b, like this is your big base, the longer value, and this is your smaller base, because you could easily reflect this entire picture, and all of a sudden you have 2 different bases if you think about it. And we also have a value that we call the height. So this value right here represents the height. So essentially you are finding the area in the middle of this by averaging the bases. An average is when you add 2 things and divide by 2, and that's what we're seeing here. And then you're multiplying that by the height. So in a lot of ways that is very similar to base times height when you're doing area of a trapezoid. And that's a lot of extra stuff, but just to tell you that all these formulas, there's Fahrenheit and Celsius, they're all legit formulas. They're not just completely made up, which sometimes we make up problems, I will be honest with you. So we're trying to get t by itself, so I think these are all multiplying because they're against each other. So I'm going to divide PR away. Currently they're multiplying, so if I just take a moment to divide those values to the other side, I now have t alone. So I'm over here, I'm looking for I being in the top and PR being in the bottom, being in the numerator and the denominator. So I'm feeling D is this option. All right, so again, please try to show some work, like demonstrate how these would be solved for. It only takes a moment to circle an answer, and that's not very useful. I mean, yeah, you may have completed your homework in a sense that you put answers down, but you really need to show your work to receive credit, and you also need to be learning how to do this because some of these questions could show up on an exam. So please bring your questions in to class so that we can spend the first few minutes talking about what you thought was correct, and then also showing the answers, but also we're not going to do every problem. So please be ready to tell me, oh, I didn't have much idea on this one or that one. Now, you cannot receive full credit unless you attempt every problem. So even if there's one that you don't know, attempt it to the best of your ability based on what we talked about, and then that gives me a baseline to look at what you thought was correct, and then it launches me into teaching you what is more correct than what you thought. So thank you so much for watching the video, and I'll see you tomorrow.